Hello everyone, welcome to this class on spreadsheets for engineers, and in this class let's learn this interpolation. You have two topics over here, that is interpolation and extrapolation. So interpolation basically means it refers to predicting values that are inside of a particular range of data points, while extrapolation it basically means predicting values that are outside of a range of data points. So let me just give you with explain that with an example. So interpol here you have three cases: perfectly linear, non-perfectly linear, and non-linear. So here there are x values and there are y values. So x values are nothing but this 2 and 3. So and y values are nothing but this so these values. So you can just see, so whenever x values are changing, so you can just see here. So whenever x values are so much, that is 10, and the y value is found to be 65, and whenever x value is 25, y value is 90. And here you have to find out. So I don't think this 2 comma 3 is required, so I'll just delete that. So here you have to find out like what could be the values of x. So what could be the value of y when the x value is 17.5. 17.5, it comes in between 10 and 25. So that is nothing but interpolation. And here in table 2, between 10 and 25 only there are many values, and you are going to determine 17 point the value of y for 17.5. And here also the similar case, but here you can just see perfectly linear. You can just see 10, for 10 the value is 65, for 25 the value is 90. That means for every values of 50, for every value y is increasing by 1.5, that means, which is nothing but perfectly linear. But here you have something called non-perfect, not perfectly linear. So though it is linear, that is, though it is increasing in a steady rate, it's not perfect. You can say 65, 68.2, 74. So here the difference is 3.2, here the difference is 5.8, here there is no difference at all. So you can just see the what to say, the increase is not so correct, so it's not so perfect. But here you can see third case, that is non-linear. So 65, 65.1, 0.3, 0.6, 66.3. So suddenly you can just see 74 to 90. So here you can see it is non-linear totally, it is not even linear. So for all these different cases, so you can just see this first and last value are the same: 10, 65, 10, 65, and 10, 65. Similarly 25, 90, 25, 90, and 25, 90. You are going to determine the value of 17.5. What could be the value of 17.5 if it is between 10 and 25? That is using all these three cases and using different formulae. One is forecast, another one is growth, another one is trend, another one is forecast dot linear. So forecasting is nothing but just like a prediction. So you're going to do that interpolation using these three formulae for all these three different cases. So but let's see what are the different values that we are going to get. So whenever we are considering the nearest values, we will get much more accurate values. For example, 17.5, the 17.5, the nearest value whichever is there is 18 and 16. Suppose if you are considering only these two as x and y values, so we might get even more accurate results. So let's try to go into this problem. So first let's try to use this growth formula. So let's try to use growth, forecast, all that. So for this case number 1, so let me try to use forecast. So let me try to use that formula. So x value is this 17.5, and known y's is this, and known x values are this. So let me close the bracket. 77.5. So 77.5 we have got it using forecast. Let me try to find it out using growth formula. Growth. So known y values are this, while known x values are this, while the new x values, so new x value is nothing but this. So let me close the bracket. Here they're asking for a constant, but let me just enter it. So 76.48. So you can see there is slight difference. Okay, so we have found out using forecast, we have found out using growth. So we'll try to use trend. So trend, there is another formula called trend. So known y's is this, while known x values is this, while new x values is this. So let's see. So 77.5. So for forecast and trend you're getting same. So let's see if forecast dot linear option is there, because in some of the versions of Excel that is not available. So yes, it's not available in this version of Excel. So let's try to leave it. There is even another method, that is the manual method. So manual method, how we are going to solve it. So let's see if we are getting the same value in manual method also. So for manual method, let me select a cell first. So here what you are going to do is, so this one is nothing but considered as x1, x2, x3, y1 and y2. So for that what you are going to do is, so let's try to select a cell first. So let me try to type equal, open the brackets. So you are going to first select y2 minus y1, y2 minus y1 divided by x2 minus x1. So again open the brackets, x2 minus x1. Fine. So for that what you're going to add is, you're going to add that using this new cell, that is this new cell minus this starting cell, that is also very important, the starting x value. So for that you're going to add that, the difference of that. So what I'll do here, I'll just go back over here. So not, you're just not going to add, you're going to multiply that. So remember that. So let me open the brackets. So for this, this let me subtract with this, and let me multiply that. And for that you are going to add the first value of y, this one. So for all this you're going to add this, so this one plus. So I hope you would have understood. So first I have taken this y2 minus y1 divided by x2 minus x1. For that I have taken this whatever the value that we are going to predict minus this. So plus the, so this one plus all this. So let me try to enter it over here. So let's see what answer we are going to get. So 77.5. So you can see 77.5 is the closest answer that we are getting in all these three cases. Similarly, you will have to find out using the other two here also. So here let's try to find out whenever it's non-perfectly linear using this growth, trend, forecast, all that. So forecast. So let me try to find out x value. X value is this, while known wise is this, while known x values are this. Enter. So you have got 77.307. So let me try to find out using growth. So using growth, so if I try to find out known y's are this, while known x values are this, well new x is this. So now let's next let me try to use trend. So again known y values are this, while known x values are this, well the new x value is this, and close the bracket. So if I try to find out using manual way also, still I would get similar way, similar answer only. So whatever I would have got it using this. So let me try to find out that as well. So equal to, so let's take the, here we'll have to take the first and the last value. So this one is y2. So let me try to go here and let me open the brackets. So I think but still there could be slight differences, but let's try. So this one minus this one divided by, so x2, so that one, let me just open the brackets. So this one minus this one. So for that what you are going to multiply is the difference of, so let me open the brackets again. So the difference of this minus this. So for that you are going to add, so you're going to add this. So I don't think there could be any change here. So 77.5, because we are going to use the numbers aren't changing too much here. So numbers aren't changing at all in fact. So the answer is not never going to change. So here let me try to use forecast. So forecast again, x is this, while known y's are this, while known x values are this. Okay, so let me try to do this using growth. So growth, known y values are this, while known x values are this, well the new x value is this. So let me try to enter, and let me try to find it that using uh, trend. So trend no y values. So the formula isn't changing at all, so it's similar. We are just comparing while how we are getting using different values. And new x value is this. So close the bracket. Okay, so now you can just see the formula, so you can make a comparison. So it isn't changing too much whenever so there are, so it's between somewhere around 70, 77, something like that only. So whenever there are non-linear, so only the first and last values are the same, but whenever it's non-linear, not perfectly linear, perfectly linear, all that there are some changes. But for this non-perfectly linear and non-linear, I'll just consider another case. Let's consider only two values for that nearest value. For 17.5, the nearest two values are the upper and lower value are nothing but 16 and 18. So what I'll do using forecast, so let me try to, so instead let me try to do that here or something adjacent to this. So if using forecast, we will try to get even more perfect value whenever we are trying to consider only the nearest value. So x value, let it be this. So known y values, I'm going to select only these two, 16 and 18, while known x values, I'm going to select only this one. So let's see what answer are we getting. So you can see 77.325. Similarly, if I try to use growth formula over there, so growth formula, so known y's is this, while known x is this, while new x is this. So you can see 77.3. So you can see it is closer whenever. So this value could be even more accurate. So 77.3, that is something but something somewhere closer. So if I try to use trend value over there, so let me select the known y's to be this, well the known x to be this, well the new x to be this 17.5. Enter. So let me try to do that using manual method also. So let me try to open the bracket. So select y2 minus y1 divided by x2 minus x1, x2 minus x1. So for that I'm going to multiply that with this one minus the first value is 16. So for that I'm going to add that with the first y value. So let's see what answer we're going to get. Okay, so let's see. So here there is some brackets issue maybe. So yes, so here okay, here I have to use multiplication. Okay, so here I might get the answer. Okay, so 77.325, you can see the 77.325 could be more accurate value. Similar way you can try to do that using this as well, like selecting the upper and lower values. For 17.5, the upper value will be 16 and lower value will be 18. So it is between 16 and 18 here in this table. So you can try doing that, so you will get even more better values. So I hope you understood this interpolation. So finding interpolation using all this. So thank you.